Hello everyone. So today we are going to solve the problem of the day. Rearrange an array with big O1 extra space. And in this problem we have been given an array of with size n, and every element in this array is in the range 0 to n minus 1. And all we have to do is to transform this array into the resultant array, which is nothing but array at array element I. So if it might sound confusing, let me write down the first test case. So in the first test case, we have array elements as 1 and 0. And let me write the index as well, 0 and 1. And this is our original array, OG. And our new array would be the, let me write down the formula for the clear understanding. So array element at array element I. So if we see at I equals 0, we have I equals 0 element is 1, and array element at 1 is nothing but 0, right? So the first element would be 0. And for I equals 1, we have array element 0. And at the 0th index, ARR of 0, at the 0th index, we have element 1. So that is our resultant array. Similarly, let us look at the second test case in which we have the elements 4, 0, 2, 1, and 3. And we have n equals 5. And let me write down the indices as well, 4. So for the now, let me write the formula as well. Now, so for I equals 0, we have array element 4, and for the array element 4, we have value 3. So the first value would be 3. And for the I equals 1, we have array element 0, and value at array element 0 is nothing but 4. Similarly, for array element 0, 1, 2, for the index 2, we have array element 2, and in the value that is stored in the array element in the array index 2 is 2 itself. So in the next iteration, we have the I equals 3. So value stored at I index 3 is 1, and the value stored at array element array index 1 is 0. And for the last, that is I equals 4, we have element stored 3 there, and at the index 3, we have element 1. So that is our result, 34201. So what we can do is, I have an idea that if I take, since we have been given that our array elements are in the range 0 to n minus 1, so if I take the modulo operation by n, suppose n was 5 here, if I take a number like 4, I get the number itself, right? Everyone knows that. So what I can do is, I now, for to find out, if you observe that for finding out the new array element, right, in the transformed array, if you see, in order to find out an element, we need two things. First, the index, and second is the value stored there. Okay, so how to store two things at one place, because we cannot use any extra space, right? We have been given that we have to solve this problem in big O1 extra space. So what we can do is, since I know that 4 modulo 5 gives me the result itself, so I can add something in this 4, that is something that is related to 3, which will give me 4 and 3 simultaneously by performing different operations. So I have think of it, and I found out that if I do 4 plus this 3, and then I will multiply this, then if I take, if I multiply this by 5, is nothing but 4 plus 3 is 7, 7 5 is 35. So what I found out was, let me clear this. If I do the array element at that particular position. So for I equals 0, say for I equals 0, we had the element 4. So if I add the element present at the fourth index, which was nothing but 3, right? Element present at fourth index was 3. Now, if I add this 3 and then I multiply it with the the size of our array, okay, 5. So I will get 19, right? And from this 19, I can divide this by 5 because I have made this 3 as a multiple of 5. So I can divide the result by 5 in order to get this 3, and I will take modulo in order to get this 4, the old value, right? So I get 3 and I get 4. Now in the next iteration, if I go on and use the same formula, I have the now this 19 has been stored in instead of this 4, right? So let me cut this 4 and store it 19. So let me again write the observation that I noted. Array element at I multiplied by n. Okay. So you have understood that by taking the modulo, I will get this original element, and for the new element, I will divide it by n. All right. Now for the next case, for I equals 1, right? For I equals 1, I had the element 0, if you remember. For I equals 1, we have element 0. So 0 plus array element at array element 1, right? So the we had 0, right? ARR of I 0, and the array element stored at 0 was 19. So if I do 19 and then I will multiply it by 5, what I'll get? I'll get 90, which is wrong. What we wanted was, now if you divide it by n, if you divide it by 5, you will get, or what you will get? You will get 19 if you divide it by 5. And if you take mod, you will get 0. But that's not what we wanted, right? That's not what we wanted. We wanted 3. If by taking the modulo, you will get the new value, and by taking the division, sorry, by taking the division, you will get the new value, and by taking the mod, you will get the old value. So by dividing, you should have got 3. All right, you should have got 3, but you have got 19. So in order to fix that, what we needed was the original value, which was nothing but 4, not this 19. So what we can do is we can make a slight change. So why, before multiplying it by n, we can take the mod by n. So we will get the original value. Understood? Because in order to gain the original value, what we were doing is to take the mod, right? So before multiplying this, uh, in order to avoid this new value, which was nothing but 90, to regain the old value, which is which was nothing but 19, we can take the mod, right? So if we take the mod, so in this case, we had 0 plus ARR of I mod n multiplied by n. So we will get 0 plus, this was 19, right? And 19 mod 5 is nothing but 4. And 4 multiplied by, and 4 multiplied by 5 is nothing but 20. Now you do, now when you divide it by 5, you will get you will get 4, which we needed as our answer, right? So let us implement this approach. And if you didn't understand the formula, you must write it down and observe it using pen and paper, because I did the same and I understood the problem. So we can iterate in the array, and ARR of I will be ARR of I plus array element at array element present at I modulo n. This modulo n we did in order to get the original result, that is 19. And when we multiply this 19 by n, we will get 4 multiplied by n, we will get 20, right? And now from this 20, what we can do is to retrieve the new elements by taking the division. I less than n, I plus plus ARR of I divide equals n. So let us compile and run and check. Let us submit the code. So yeah, it got submitted. It should be. Yeah. Thank you.